Hi, Mrs. KJ here, going over 3.06 Review, Measuring pH. Review concepts presented in the lessons, measuring acids and bases, and buffers and titration. There is much to know and understand about acids and bases. The pH of a solution tells you whether it is acidic, basic, or neutral. Buffers are used to keep the pH of a solution constant, and titration can be used to determine the concentration of an acid or base. Goals for this lesson: demonstrate mastery of important knowledge in the lessons, measuring acids and bases, and buffers and titrations. Online review. So you're going to be reviewing. The student guide is here, which does have the solutions for the problems that we will be doing. Key concepts in measuring acids and bases. The pH scale is used to indicate how acidic or basic a solution is. Substances with a pH equal to 7.0 are neutral. Substances with a pH greater than 7 are basic or alkaline. Substances with a pH of less than 7 are acidic. You can calculate the pH of a solution by using this formula. pH equals the negative log of the concentration of hydrogen ions. And remember, the pH scale goes from 0 to 14. pH indicates acidity, values less than 7, neutrality, values of 7, alkalinity, or being a base, with values greater than 7. Key concepts in buffers and titration. A buffer is a mixture of an acid and a base that keeps the pH constant in a solution. A buffer is often composed of an acid and its conjugate base. Titration is a process by which the concentration of an acid or base can be determined. The equivalence point is the point in a titration at which the number of moles of hydroxide ions is equal to the number of moles of hydrogen ions. pH is stabilized by or kept constant by buffers. Remember, not kept neutral, kept constant. pH is determined by titration, which uses indicators like phenolphthalein and is based on neutralization reactions. Organize key concepts in the lessons you have studied. So go ahead and hit pause and put the answers where they need to be. And I will show the answer in 3 seconds. So check your answers. Now look at some model problems. So remember, to get to your problems, you need to scroll up under the top, go to Problems and a Solution Guide, and then click here to access the book. So problem set 72, measuring acids and bases. Scientists use the pH scale to determine the acidity or alkalinity of solutions. There are many different ways to define acid and base. The Arrhenius, Bronsted, Lowry, and Lewis definitions of acids and base apply to specific chemical substances. In many cases, however, the question is whether a particular solution, rather than a particular chemical, is acidic or basic. One way to define an acidic or basic solution is by its reaction with litmus paper. Acidic solutions turn blue litmus paper red, and basic solutions turn red litmus paper blue. However, in most cases, a more quantitative method of determining the acidity or alkalinity of a solution is needed. Scientists use the pH scale to define quantitatively how acidic or basic a solution is. Solutions with pH values between 0 and 7 are said to be acidic. Solutions with pH values between 7 and 14 are said to be basic. Solutions with a pH of 7 are said to be neutral. All right, so again, there's our scale. It goes from 0 to 14. Okay, and we're going to go over a few examples. Let's read the tip. When the hydronium ion concentration of a solution is equal to 1 multiplied by the power of 10, the pH of the solution is equal to the negative of the power of 10. For example, the pH of a solution with a hydronium ion concentration of 1 times 10 to the negative 9th molar, the pH is 9. Calculate the pH from hydronium ion concentration. On average, carbonated water has a hydronium ion concentration of about 1 times 10 to the negative 4th molar. Remember that capital italicized M is molarity, the number of moles of solute per liter of solution. In contrast, a 0.1 molar solution of sodium bicarbonate, or baking soda, has a hydronium ion concentration of about 3.98 times 10 to the negative 9th molar. Calculate the pH of each solution and identify whether it is acidic or basic. So here is our equation. And our first concentration is 1 times 10 to the negative fourth. So it's pH times the negative log of the hydronium ion concentration. pH, negative log of 1 times 10 to the negative fourth, is going to give you an answer of 4. For the sodium bicarbonate, we're going to do pH negative log of 3.98 times 10 to the negative 9th, and our answer is 8.4. So again, we can estimate. We know this answer should be exactly 4 because it's 1 times 10. This answer, 3.98 times 10 to the negative 9th, the answer should be somewhere close to 9. It's 8.4, pretty close to 9. 4, is that an acid or base? It's an acid. 8.4 is a base. All right, what if we want to work backwards? Calculate the hydronium ion concentration from pH. A student measures the pH of pure water and finds it to be 7. The student adds some nitric acid, HNO3, to the water, and the pH drops to 0.82. Calculate the hydronium ion concentration of the pure water and of the HNO3 solution. All right, so again, know your equations. pH equals negative log of the concentration of hydronium ions. Now what we're going to do is we're going to solve for the concentration of hydronium ions. So we multiply both sides by -1, so we move the negative over to the left, and then we have to move the log. And in order to do that with the math, it becomes 10 to the negative pH equals 10 to the log of the concentration of the hydronium ion equals your concentration of the hydronium ion. So substitute the given values in the equation for pure water. The equation is as follows. The concentration of the hydronium ion equals 10 to the negative 7th, which equals 1 times 10 to the negative 7th molar. And for the nitric acid solution, the concentration of hydronium ions equals 10 to the negative 0.82. Okay, so it's 10 to the negative pH. Here's our equation right here, 10 to the negative pH. So the pH was 0.82. We just take 10 to the negative 0.82 to get your answer of 1.5 times 10 to the negative 1 molar. All right, and then for this lesson, we needed to do questions numbers 1, 2, and 3. Question 1, the solution of acetic acid has a hydronium ion concentration of 3.6 times 10 to the negative 6 molar. What is the pH of the solution? The hydronium ion concentration of a solution of sodium sulfate is 3.61 times 10 to the negative 8 molar. State whether the solution is acidic or basic without calculating the pH. And number 3, typical cola soft drinks have pH values of about 2.8 to 3.4. What is the range of hydronium ion concentration for cola soft drinks? So hit pause, figure them all out. Once you have them figured out, play again, and I'll go through the answers. So question 1 was 3.6 times 10 to the negative 6 molar. That was the concentration, so we're going to put that in here. We're going to take the negative log of 3.6 times 10 to the negative 6, and our answer is 5.4. Question 2 was talking about how we had 3.61 times 10 to the negative 8. Was it an acid or a base? Well, because it's the power to the negative 8, you should know that the pH is going to be about 8. Okay? And if you want it to be more exact, it's probably closer to 8. Either way, it's more than 7, so it's going to be basic. And question 3 gave you the pH values, so we had to rearrange our equation to get hydronium ion concentration equals 10 to the negative pH. There we go. See that a little better. Sorry about that. And then we are going to simply put in the math. And I gotta get a little bit smaller there. There we go. Sorry about that. So a pH of 2.8 yields a hydronium ion concentration of 10 to the negative 2.8, which means that the concentration is 1.6 times 10 to the negative 3 molar. A pH of 3.4 yields a hydronium ion concentration of 10 to the negative 3.4, which equals 4 times 10 to the negative 4th molar. Therefore, the range of hydronium ion concentrations in cola soft drinks is 4 times 10 to the negative 4th molar to 1.6 times 10 to the negative 3rd molar. And now we have to go through problem set 72, measuring acids and bases. And I'm actually going to pause here and end the video, so we'll start this in our next video to make sure that it all goes on the same video. So go ahead and watch the next one.